Like, subscribe, and hype the video. Also, leave a comment on any topics you want to hear about in the future. Okay, let's dive in. At the very center of our galaxy, roughly 26,000 light-years from where you're sitting right now, something unimaginably massive is hiding behind a thick curtain of gas and dust, so dense that no ordinary visible light can penetrate it. For most of human history, we had no idea it was there. It couldn't be seen, couldn't be photographed in any traditional sense, and gave away its presence only through the behavior of everything around it. Stars moving at speeds that made no physical sense unless something extraordinarily massive was pulling on them from a single, fixed point. What we eventually found there, after decades of painstaking observation, using telescopes that see in wavelengths completely invisible to the human eye, is one of the most extraordinary objects ever confirmed in modern science. A supermassive black hole, roughly 4 million times the mass of our Sun, sitting at the gravitational heart of everything we call home. Its name is Sagittarius A star. And today we're walking through exactly what it is, how we know it's there, what the stars dancing around it look like up close, and what the first real photograph of it revealed when it was finally captured in 2022. In our next episode, we'll get into the stranger, wilder claims surrounding the galactic center, including theories about what might actually be powering it that go well beyond mainstream science. Stick around for that one. But first, let's understand exactly what's actually there. The story of how we confirmed a supermassive black hole at the center of our galaxy is one of the most patient, methodical detective stories in the entire history of astronomy, because the object itself, by definition, emits no light that we can see directly. The galactic center sits in the direction of the constellation Sagittarius, but the actual core of the Milky Way is completely hidden from view in visible light by enormous clouds of interstellar gas and dust that block the light like a permanently drawn curtain. Astronomers have to observe this region using infrared light, radio waves, and X-rays, wavelengths that can penetrate the dust clouds where visible light cannot. Starting in the 1990s, two independent research teams, one led by Reinhard Genzel at the Max Planck Institute in Germany, and one led by Andrea Ghez at UCLA, began using infrared telescopes equipped with a technology called adaptive optics, systems that can counteract the blurring effect of Earth's atmosphere in real time, to observe stars in the region very close to the galactic center with unprecedented precision. What they found tracking these stars year after year was something extraordinary. Like, subscribe, and hype the video, because what those stars were doing near the center of our galaxy completely changed how we understood what was there. Over years and then decades of observation, both teams built up a detailed picture of how stars in the immediate vicinity of the galactic center were moving, and those movements were extraordinary by any standard. A group of stars, now designated stars, were found to be orbiting an invisible central point in extremely tight, extremely fast elliptical paths. One of them, a star called S2, completes a full orbit around the galactic center in just about 16 years. An orbit that at its closest point brings it to within a distance of only about 120 times the Earth-Sun distance from whatever sits at the center, and at its fastest point sends it moving at roughly 3% of the speed of light. 3% of the speed of light is approximately 11,000 miles per second. For context, Earth moves around the Sun at roughly 18.5 miles per second. SU moves roughly 600 times faster than that at its closest approach to the galactic center. For a star to move this fast on this tight an orbit, the object at the center pulling on it had to be extraordinarily massive and extraordinarily compact. Calculations based on these orbital measurements produced an estimate of roughly 4 million solar masses confined to a region smaller than our own solar system. There is only one known class of object in all of physics that can pack that much mass into that small a space: a supermassive black hole. For decades, the evidence for Sagittarius A star was entirely indirect, built from the orbital behavior of surrounding stars rather than any direct observation of the object itself. Then, in May of 2022, The Event Horizon Telescope collaboration released something that had never existed before, an actual image of Sagittarius A star. The Event Horizon Telescope isn't a single instrument. It's a global network of radio telescopes spread across multiple continents, coordinated to work together as a single, Earth-sized virtual telescope with enough resolving power to image the region immediately surrounding a black hole's event horizon at the center of our galaxy, 26,000 light-years away. The same collaboration had previously released the first-ever image of a black hole in 2019, targeting the much larger supermassive black hole at the center of the galaxy M87. Sagittarius A star was harder to image because despite being much closer, it's also much smaller and changes more rapidly than M87's central black hole, requiring significantly more complex data processing to produce a usable image. What the image showed matched almost exactly what theoretical physics had predicted decades in advance: a bright, glowing ring of superheated gas and plasma surrounding a dark central region, the shadow of the event horizon itself. Light bending around the black hole's enormous gravity, forming a circle of brightness around an area of complete darkness. The image confirmed, visually and directly for the first time, that what sits at the center of our galaxy is exactly what the orbital calculations had been pointing to for decades. Like, subscribe, and hype the video. And let's talk about what this thing is actually doing on a day-to-day basis. Here's something that surprises most people when they first learn about Sagittarius A star. For its size, it's remarkably quiet. Many galaxies host supermassive black holes that are actively feeding on enormous amounts of surrounding gas and dust, producing spectacular jets of energy and blazing with so much radiation they can outshine every star in the galaxy combined. These active galactic nuclei, sometimes called quasars, are among the most energetic objects in the known universe. Sagittarius A star, by comparison, is currently in a relatively dormant, low-activity state. It still flares occasionally. Astronomers regularly detect brief bursts of X-ray and infrared emission from the region, likely caused by small amounts of gas and dust falling across the event horizon. But these flares are modest by galactic standards, and for most of the time, the 4 million solar mass black hole at the center of our galaxy is sitting quietly, not consuming nearly as much material as many of its counterparts in other galaxies. This hasn't always been the case. Evidence from gas clouds and X-ray echoes in the galactic center region suggests that a few million years ago, Sagittarius A star was significantly more active, possibly shining hundreds of thousands of times more brightly in X-rays than it does today, during a period when it was consuming material at a much higher rate. We happen to live in a relatively calm era of galactic history, at least by the standards of what our galaxy's own central black hole is capable of. One of the most genuinely puzzling aspects of the galactic center region is something astronomers discovered when they looked closely at what surrounds Sagittarius A star, a population of young, massive stars orbiting within a surprisingly short distance of the black hole itself. This is puzzling because the environment immediately surrounding a supermassive black hole is, by any physical reasoning, one of the worst imaginable places for new stars to form. The tidal forces from the black hole's immense gravity would normally tear apart any cloud of gas and dust before it could collapse under its own weight and ignite nuclear fusion, the process that actually creates a star. The region should, theoretically, be hostile to star formation. And yet, the stars are there. Young, hot, massive stars that couldn't have migrated from farther out in the galaxy in their short lifetimes, which means they had to form close to where they currently sit. How star formation happens in such an extreme gravitational environment is still an active area of research, and one of the interesting open questions about the center of our own galaxy. The kind of detail that reminds astronomers that our understanding of even the neighborhood we live in is still genuinely incomplete in some places. So that's Sagittarius A star, a 4 million solar mass black hole sitting at the gravitational center of our galaxy, confirmed through decades of patient star tracking. Finally, photographed directly in 2022, currently quiet by galactic standards, but capable of far more dramatic activity than it's showing right now, and surrounded by young stars that by all rights shouldn't be able to form that close to it at all. In our next episode, we're looking at the stranger claims surrounding the galactic center, including theories about what might be powering it beyond mainstream physics. The idea that galactic center radiation events have triggered mass extinctions on Earth in the past, and the even more exotic claims about what the galactic center might represent that have circulated in certain communities for decades. Some of what we cover in that episode is going to go places this one didn't. Stick around for that one. Like, subscribe, and hype the video so you don't miss part 2. And let me know in the comments what you find most surprising about what's actually at the center of our galaxy. I'll see you in the next one.